So, hello everyone, my name is Dhananjay Mankar and today I'm going to teach you quadratic equation. So, as you all know that quadratic equation, when you write a polynomial expression ax square plus bx plus c and equate it to 0, then it becomes a quadratic equation where a, b and c, they all are numbers, they belong to real numbers, okay? And x, as you all know, x is a variable. X is a variable and A, B, C are constants. Okay, so I hope this is clear to you. And there is one more important condition, that is A is not equal to 0. Why? Because if A becomes 0, then 0 into x square plus bx plus c equal to 0, and 0 into something is 0. So the equation reduced to bx plus c equal to 0. It means now the highest power of the variable is 1. Therefore, it is not a quadratic equation, it is a linear equation. So for equation to be quadratic, most important condition is a must not be equal to 0. Okay, so this is the basic of quadratic equation. And as you all know, a linear equation gives you only one value of x. Just a second. Okay, if you solve a linear equation, you get only one solution, and if you solve a quadratic equation, you will get two solutions, and in this case we call them roots of the quadratic equation. Okay, so the highest power of the variable is x. Just a second. Variable is x, and the highest power of variable is 2. Therefore, it has two roots. Okay, so I hope this thing is clear to you. Now we are going to learn. Suppose I say x square equal to 4, x square equal to 4. Is this a quadratic equation? Yes, it's a quadratic equation because the highest power of variable is 2. And if it is a quadratic equation, it must give two solutions. Therefore, we can say that x equal to plus or minus 2. A solution or root means the value of x which satisfies the given equation. Okay. For example, if I put x equal to 2 in this equation, the left hand side becomes 2 square, that is 4, is equal to left hand side, and right hand side is already 4 is given. Okay, so by putting x equal to 2, LHS become equal to RHS. Therefore, x equal to is one of the solution. And similarly, x equal to minus 2, if I put x equal to minus 2, then minus 2, square of minus 2 is 4. Therefore, again, left hand side becomes 4 and right hand side is also 4. Therefore, x equal to minus 2 and plus 2 are the solution of this equation. Okay. Now there is one more question for you. If I say ax square plus bx plus c equal to 0 is a quadratic equation, then it is possible for which option? All values of a, all non-zero values, all non-zero values of a, b or c. Okay, so this is a very easy question. You must take all non-zero values of a. because I told you earlier if a becomes 0 it will not be a quadratic. Okay, so correct option is option. Let's move to the next slide. Now there is one question for you. If one root of the quadratic equation, then one root of the quadratic equation, 2x square plus ax x square plus ax minus 6 equal to 0 is 2, then find the value of k. Okay, so this is a very easy question. The given equation is 2x square plus ax minus 6 equal to 0. Okay, and its one of its root is 2, and I told you earlier if 2 is the root of this equation then 2 must satisfy this equation. Therefore if I put x equal to 2 then it will become 2 into 2 square plus 2k minus 6 equal to 0. So 8 plus 2k minus 6 equal to 0. It means 2k plus 2 equal to 0 means k equal to minus 2. It means k equal to minus 2 upon 2, that is minus 1. Therefore, the value of k is minus 1. Okay, so you will get this type of equations in your board exam. Okay, now let's move on to another question. Just a second. So there is one more thing. If ax square plus bx plus c equal to 0 is a quadratic equation and it has two roots alpha and beta, then sum of roots written as alpha plus beta, and there is a relation between these roots and these coefficients a, b and c, and the relation is sum of roots becomes equal to minus b upon a, and there is one more relation, product of roots, that is alpha into beta equal to c upon a. Okay, so you have to use this relation to solve some questions. Now we'll move on to the factorization method, that is how to find the roots of the quadratic equation using factorization method. Factorization method. Okay. So let me take an example. I give you a quadratic equation x square plus 6x plus 5 equal to 0. Okay. So this is a quadratic equation and you have to solve this quadratic equation using the factorization. So what we'll do, the coefficient of x represent the sum. So sum should be 6 and product is this constant term 5 and the coefficient of x square which is 1. So the product is 5 into 1. The product is 5 into 1, that is 5. So I have to break this middle term or split this middle term into two parts such that the sum becomes 6 and the product becomes 5. So I can write this as 5 and 1, or I can split into 5 and 1. For example, I can write x square plus 5x plus x plus 5. So 5 into 1 becomes 5 and 5 plus 1 becomes 6. Okay. Now if I take the common x, these first two terms, so you'll get x plus 5 inside, and from this second part I get 1 as common. I can write x plus 5 inside the bracket. So if I take x plus 5 common now, I'll get x plus 1 as another factor, and this is obviously equal to 0. So you'll get two different factors. Now if you have to find the roots, put this factor equal to 0. Okay. So x equal to minus 5 one root, and x equal to minus 1 is another. Okay. So that's the solution. Now let us take one more example. Let's move on to the next slide. Okay, if I write the quadratic equation as 8x square 8x square minus 22x minus 21 equal to 0. So I have to break this middle term or split this middle term into two parts such that the sum becomes minus 22, sum becomes minus 22, and product becomes minus 21 8, that is minus 168. So what you have to do is you have to factorize this 168. So in the very basic method you can write it as 2 8s are 16 and 2 4s are 8, 4s are 8, 2 2s are 4, 2 2s are 4, and have to divide it with 3, 7s are 20. So you can write 168 as, you can write 168 as 2 into 7. Now you have to pair these parts into two different numbers such that its products become 1 minus 168 and its sum becomes minus 20. So if I take these 2 into 2 4 and 7, so 4 into 7 becomes 28, and this 2 into 3 becomes 6. So the product is negative, one number must be positive and one number must be negative. So I have to get the sum as, just a second. I have to get this sum. Okay, I have to get this sum as minus 22. So the bigger number must be negative, that is minus 20, a smaller number must be positive. So I have to break this second term minus 22x in the form of minus 28x plus 6x minus 21 equal to 0. Now if I take 4 as common in the first two terms, so 4x I'll take common, and inside the bracket I'll get 2x minus 7. And if I take 3 as a common, get 2x minus 7 inside the bracket. So now I'll take out 2x minus 7 as a common term. Then I'll get another factor as 4x plus 3. Now you have to get the roots. You have to put these two factors equal to 0. So 2x equal to 7 or x equal to 7 by 2 is one of the roots, and x equal to minus 3 or x equal to minus 3 by 4 is another. Okay. So here is, so this is the method. This is how you have to solve the quadratic equation using the factorization method. Okay, I'll take one more example for you. So let's try some different type of question. Okay, so if I give you the quadratic equation as x minus 1 square minus 5x minus 1 minus 6 equal to 0, then what will do? There are two methods to solve this equation. First method is you can expand this equation like a minus b whole square. So you can write it as a square minus 2ab plus b square, and open this bracket, minus 5x and plus 5 minus 6 equal to 0. So then keep the like terms, add the like terms. So minus 2 minus 5 becomes minus 7x, and 1 plus 5 becomes 6 and minus 6. So these two terms will cancel out and you'll get x square minus 7x equal to 0. Now take x as the common term, get x minus 7 as another factor. Put these two factors equal to 0 separately. You'll get x equal to 0 as one root and x equal to 7 as another. Okay. Now I'm going to tell you one another method to solve this question. And this method is you can take or you can write x minus 1 equal to 2 as equal to t as another variable. So the equation reduces to t square minus 5t minus 6 equal to 0. Now sum is minus 5 and the product is minus 6. So I can break it as sum is minus 5, okay, minus 6 and 1. I can break it into two factors, t square, because minus 6 plus 1 becomes minus 5 and minus 6 into 1 becomes minus 6. So it is satisfying both these conditions. Okay, so I can write minus 5 to is minus 6t plus t minus 6 equal to 0, and I can factorize it as t minus 6, and one common from the second two terms, t minus 6. So t plus 1 and minus 6 equal to 0. So I'll get t equal to minus 1 or t equal to 6. Now replace this first equation. So x minus 1 becomes minus 1. Is x is 1 minus 1, that is 0. 0 is one root, or x minus 1 equal to 6. Such that x equal to 6 plus 1, that is 7. This is another root. So these are the two different methods to approach this question. Okay. Now let's take the last example of this type. Okay, let us take another question which has some irrational number attached to it. Okay, so let me take an example of x square plus 5 root 3 x plus 12 equal to 0. Now there is no need to panic. We get here root 3, and root 3 is disturbing you, I know that. Okay, but there is no need to worry. Now you can just write sum as 5 root and product as 12. Okay, now just think, the sum of two numbers is 5 root 3. Therefore, both these numbers must contain root 3. Okay, and both these numbers must contain root 3. It means you'll get product as root 3 into root 3. Okay, now you have to think about this constant term. Root 3 into 3 becomes root 3 into root 3 becomes 3. The extra term is 4. Okay. Now you can write it as 4 root 3 and root 3. So if I add 4 root 3 plus root 3, it becomes 5 root 3. And if I multiply 4 root 3 into root 3, it becomes 12. Okay. So these two conditions are satisfied now. So I can break the middle term as x square plus 4 root 3x plus root 3x plus 12 equal to 0. So sum of roots becomes 5 root 3 and product of roots becomes 12. Now take x as common. Inside the bracket we'll get x plus 4, and from these two terms if I take root 3 as common, I'll get x plus 4 root 3 inside the bracket. So take the x plus 4 root 3 as common, and inside the bracket we'll get x plus root 3 equal to these two terms equal to 0. So x equal to minus 4 root 3 and x equal to minus root. These are the two roots of this equation. So now you can solve these questions which contains the root. There is no need to panic. You'll always get factor of root 3 into root 3 in the product. Okay, so you do not worry about this. Now take another example which does not contain any particular value, means it contains only variables and constants a, b, and the constants are also not given as a number. Okay, it means, let me write the equation first. 1 upon a plus b plus x equal to 1 upon a plus 1 upon b plus 1 upon x, and it is given that a plus b is not equal to 0. Okay, so how you can solve this type of equation? First, bring the variable to one side and the constants on the other side. So I can write it as 1 by a plus x minus 1 by x equal to 1 by a plus 1 by b. Okay. Now if you take the LCM, then x minus a minus b minus x on plus b plus x into x equal to get a plus b factor ab. So x and x will cancel out. So on the top it becomes a plus b, and this term becomes ax plus bx plus x square equal to a plus b ab. So a plus b gets cancelled out and the equation becomes cross multiply both the sides, minus ab equal to ax plus bx plus x square. So if I rewrite it as x square plus ax plus bx plus ab equal to 0. So I can take x common from the first two terms. Inside the bracket I'll get x plus a, and I take b as common. The third and fourth term get x plus a inside the bracket. Okay. So if I take x plus a as common, the second term I'll get x plus b as common. Okay. So if I get the roots, I'll get x equal to minus a as one root and x equal to minus b as another root. Okay. This is how you have to solve the quadratic equation using the factorization. I hope this video lecture is clear to you all. Okay. See you soon. Take care. Bye bye.